All right, let's look at the 2022 AP Calculus exam problem. This is question number 1. I have not read the question yet. I've been teaching AP Cal for about 17 years, so you're going to watch me read the problem and solve it in real time. So here comes question number 1. Let's see. So vehicles are arriving at a toll plaza at this function. T is measured in hours after 5 a.m. in vehicles per hour, traffic, blah, 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 blah. Right, but don't evaluate an integral expression that gives the total number of vehicles that arrive from this time to this time. Okay, so first thing I'm going to do is go to my calculator and define that function. So this is called A of t in the description. So define A of t equals 450 square root of the sine of 0.62t. Make sure I got that in there correctly, because last year I fat fingered my function and missed all the problems. Okay, so I'm going to make some notes to myself. We're going from 5 to 10, the rate in. So this looks like it's a rate in, rate out, and at the moment we do not have a rate out. So the rate in is A of t. That is measured in vehicles per hour. And t equals 0 is 5 a.m. So t equals 0 corresponds to 5 a.m. Okay, so right, but do not evaluate an integral expression that gives the total number of cars that arrive at the toll plaza from 1 to 6. That's going to be a quick one. The number of cars that arrive will be the antiderivative of that A of t, which was actually capitalized. Let me fix that. A of t dt measured from 1 to 5, and I'm surprised we don't have to evaluate it with this being a calculator question. But that is your answer. I'm right, but do not evaluate. Yeah, okay, whatever. We're done with part A. Part B, find the average value of the rate. The average value, so this is an average value theorem question, so that would be 1 over 5 minus 1, and they want the average value of the rate. And A of t is the rate. So it's going to be the antiderivative from 1 to 5 of A of t. So let me rewrite that. 1 over 5 minus 1, antiderivative 1 to 5 of that function A of t. Make sure you set that up correctly. Then you can write the answer. So I'll go to my calculator. Control divide. 1 over and 5 minus 1 would be 4, not 5. Shift plus, we're going 1 to 5 of my previously defined function, A of t dt. I'm going to hit Control Enter to force the decimal, and I'm getting 375.565369, and they don't ask us to round, so double check that, find the average value of the rate. Okay, that's good. So 375.537, 375.537. Do they ask for units? No, the units are implied in the question. So I'm going to leave part B like that one. Is the rate at which the vehicles arrive at 1 increasing or decreasing? So they want to know if the rate is increasing. So we need to know if the rate's derivative is positive or negative. So I'm going to find A prime of 1. They ask specifically at t equals 1. So I'll go to my calculator and I'll use my derivative at a point command. So menu, calculus, derivative at a point. I'm going to plug in, I'm going to use t for my variable. I'm going to plug in 1. It will compute the derivative of A of t at t equals 1. That looks good. Control Enter, and I'm getting 148.947. That is a really big number. Usually these questions are closer to 0. Anyway. All right, so 148 point, what'd I say? 947. Okay, that is a positive value that is greater than 0. Therefore, the rate cars arrive is increasing. So the rate, it is the rate increasing or decreasing, is increasing at t equals 1 because, I should write that out, because A prime of 1 is greater than 0. So there's my answer for part C. And number D, a line forms whenever A of t is greater than 400. The number of vehicles in line from that time when A is greater than 400 until 4 is given by N of t equals that. Where A is the time when the line first begins to form. So we're going to have to find out when A of t is equal to 400, I'm thinking. A of t equals 400 will lead to some value that I will get in a minute. To the nearest whole number, find the greatest number of vehicles on the interval A to 4. So we're looking at an absolute maximum question. So I'm going to go to my calculator. I'm going to graph my function A of t, although in the function grapher, you have to do the function of x. I also need to graph the line 400. And I am going to adjust my window. I know my x's need to go from 0 to at least 400. I'll go to 600 to give me some breathing room. And that's not correct. My x's need to go from 0 to 4. And my y's need to go from 0 to 600 with an automatic whatever. There is my graph right there. And oh crap, I just edited my graph. There we go. Student just came in, so I'm going to pause this for a second. Okay, so I'm going to find these two intersections. So menu, analyze, intersection, and there is 1. So I'm going to store that for A. Syntax error, don't give me that. Control store, maybe I can't use A because A is my function. So I'm going to store that for B. Control store for B. There we go. And then I'm going to go ahead and find my other intersection. Menu, analyze, intersection. And I'll store this one for C. Enter. All right, so there are my two intersections. I'm going to make a note to myself that A of t is greater than 400 on the interval 1.469 less than t less than 3.598. And I'll make a note to myself that that is stored for A, and this one is stored for B. And I have to sneeze. All right, so there's that. Okay, now back to the question. A is the time when the line first begins to form, and the line forms when A is greater than 400. So the line starts to form at this, that's not A, this is B, at 1.469. To the nearest whole number, find the greatest number of vehicles. Okay, so N is the number of vehicles. So if I want the greatest number of vehicles, I will need to find the critical numbers of that function N. So N prime of t is going to be the function A of t minus 400. I will need to set that equal to 0 to get my critical numbers. I'll stick with blue. And I actually just solved that. I know that happens at 1.469 and 3.598. And I basically just recreated some work I already had. And now to find the question is it asking when or what is the number of cars? Find the greatest number of vehicles and justify. So my candidates are my endpoints, which will be 1.469 and 4, because they define 4 to be the end of the interval. And also my critical numbers, which happen at t equals 3.598. And then the greatest number of vehicles, I'm simply going to find the number of vehicles at each of those candidates. So my number of vehicles at B, which is 1.469, will be the antiderivative from A. Oh, that's going to be B. So from, see, I wish I hadn't stored A because now I've messed myself up because they define this as A and I'm calling it B. Okay, so I now know that that value of A is 1.469 to that same value of A of t minus 400. That will obviously be 0 because we're not going anywhere. My number of vehicles at my critical number, which was stored for C, 3.598, would be the antiderivative from 1.469 to that value of C. And we will go to the calculator and figure that out. And I'm going to go ahead and set up my last antiderivative before I go to my calculator. That will be the number of vehicles at time 4, which will be the antiderivative from 1.469 to 4 of A of t minus 400. And now we will punch all of these, or these last two, into the calculator to get our number of vehicles at each of those times. So back here, shift plus. Now I stored that lower value for B, so I'm having to be careful there. B2 C of the function A of t. Where's t? A of t minus 400 dt, control enter. And then I'll go ahead and do the next one as well. That was from B to 4. We have 71.254. And the other one was 62.338. And so the answer to the question, find the greatest number of vehicles, justify your answer to the nearest whole number. So make sure you round. So the greatest number of vehicles is 71, because we will round that down. And if you want to be thorough, you could say at time t equals, and that occurred at my value of C, which is 3.598. That is a little bit overkill. And if you write something like that and you're wrong at the time, then that will count against you. But there is my answer to question number 1. Let's move on to number 2.